Welcome, Algebra 2 students, to the Chapter 8 review sheet. Let's go ahead and get started on page 449. Let's start off with numbers 1 through 9 odd, and the directions say to, let me turn over to that page, use a calculator to evaluate, round to 3 decimal places. So here we go, 8 to the pi power. Alright, so on your graphing calculator or on any calculator, if you don't have a grapher, you'll have to find the pi button. But on a grapher, it's the sorry about that, let's fix that real quick. It's the very last column right here on the right. And it's the second button down. Here's the clear button. And then here's your arrow button. Right above the arrow button is your pi. So you want to hit shift and arrow for your pi button, okay? So what you want to do is you want to hit 8. Then of course it's going to be an exponent, so hit your arrow button, alright? And then hit second arrow and pi is going to pop up, okay? Like this. And then hit enter. Round to 3 decimal places, so 687.291, alright? 687.291. Number 3. Alright, this is a simple logarithm problem. Is it a base E? No. If it was, you could use this button here, natural logarithm. Is it a base 10? No, I wish it was. If it was, you could use this button right here, your logarithm button. But it's not a base 10, it's a base 6. So remember, we have to type into our calculator logarithm of 10 divided by logarithm of 6. Okay? So it's your logarithm button. 10 equals divided by logarithm of 6 equals, and you will get 1.2850. So we round to 3 decimal places. 1.285. Number 5. Natural logarithm of 4. Remember, this is a base E. Our calculator does this for us. So on your calculator, push the natural logarithm button, the LN button, and then 4, and then enter. Alright? And you will get this right here, 1.3862. Because of the 2, we leave the 6 alone. So our answer is 1.386. Number 7. Alright, e to the 4.2 power. So we're going to have to type in the E button, okay? So hit the E button, and this will pop up. E to the arrow, or E arrow to a certain power, then type in 4.2, and then hit enter, alright? And you will get 66.6863. Because this is a 3, we leave the 6 alone. So your answer is 66.686. Alright, moving on to number 9. Pi to the E power. Okay, no problem. First of all, we're going to hit this. Actually, this is a problem. It's going to be challenging, so listen carefully, okay? Before we even tackle this problem, let's forget this problem for a second, okay? If I asked you what E equals, what do you do? Well, E is really E to the what power? 1. So you would hit your E button, and then this pops up, of course. Then put a 1 and hit enter, and that gives you the value of E, okay? So with that in mind, let's do this now. Let's type in pi. So with your calculator, go ahead and hit pi, and this will pop up on your screen. Then you have a power, so hit your arrow button, and this will pop up, alright? Now, next, you want e to the 1 power. So you've got your exponent. You're telling your calculator that the next thing I teach is the exponent. So hit your E button, and this will pop up. So now you've got pi arrow, then E arrow, and then put a 1 because E is to the 1 power. And then hit enter, and you should get 22.4591. And this 1 means that you leave the 9 alone. Alright, students, let's move on now to numbers 10 through, let me look at my sheet here, 10 through 15. The directions say to evaluate without a calculator. So here we go. These are going to be tough, okay? Alright, so I have logarithm base 2 of 16 equals x. Okay? Next, I write it exponentially. So 16 equals 2 to the x power. Remember, when you don't know what the logarithm equals, You set it equal to x, okay? Now, we try to write both sides with the same base. Well, I can definitely write 16 with a base of 2. 2 to the 4th power, right? Equals 16. So for 16, I can put 2 to the 4th power. And look at that, guys. Look. This has to be a 4 because 2 to the 4th power equals 2 to the 4th power. So x has to be a 4. So your answer is 4. Alright, number 11. We're doing this without a calculator. So we admit that we do not know the answer. We set it equal to x. Next, we rewrite it exponentially. So 64 equals 4 to the x power. Now, there's actually two ways to do this. I'll work it out both ways. We want to write both sides with the same base, correct? Sure we do. Well, 4 times 4 is 16 times 4 is 64. In other words, 4 to the 3rd power is 64. Okay, so for 64 I can put 4 to the 3rd power. And for 4 to the x, it stays 4 to the x. Okay, obviously x is 3. 4 to the 3rd power equals 4 to the 3rd power. So x is 3. Now there's another way to do it. It's a little longer, but there's another way to do it, okay? 2 to the 6th power is 64. 2 to the 6th power is 64. So for 64 I can put 2 to the 6th power. And then for 4 I can put 2 to the 2nd power and bring down my x. Now this is definitely the worst way to do it, but I'm still going to show you this, okay? So for 4 you can put 2 squared. For 64, 2 to the 6th. Now, when you have two exponents like this, you multiply them together. So 2 times x is 2x. 2 times x is 2x. Now, you have like bases, so this exponent here has to equal this exponent here. So 6 has to equal 2x. Divide both sides by 2, and 3 equals x. Either way, you get the same answer, okay? Alright, number 12. This is the easiest problem we'll do. You can never, ever take the logarithm of a negative number. Never, okay? So the answer is undefined or no solution. Number 13. Okay, here we go. Logarithm base 2 of 1/8. Okay, we do not know what it equals, so we set it equal to x. Next, we write it exponentially. So 1/8 equals 2 to the x power. Now, it does not take a rocket scientist to see that we have a fraction here and not a fraction here, so we're somehow going to have to take care of that, okay? Eventually. But first of all, the first thing I notice is that an 8 can be rewritten with a base of 2. 2 to the 3rd power equals 8. So where the 8 is, I'm going to put 2 to the 3rd power. Just like this, okay? There we go. Now, next, I don't want this fraction. So let's take this 1 over 2 to the 3rd. Let's work with it, okay? 1 over 2 to the 3rd. Obviously, I don't want a fraction because I don't have a fraction over here. So bring this 2 to the 3rd up top. When I do, the 3 becomes negative. So now I have 1, which was up top already, times 2 to the negative 3rd power, all over 1. Okay, well, 1 times anything is just itself, 2 to the negative 3. And anything over 1 is just itself. So now I have 2 to the negative 3. So 1 over 2 to the 3rd equals 2 to the negative 3rd power. Now students, if you don't quite understand where this came from, look again over here, okay? We had 1 over 2 to the 3rd power. We realized we didn't want a fraction, so we brought this up top, which made this 3 become negative. The base does not change, the exponent changes. So now I have 2 to the negative 3rd equals 2 to the x. Well, I have like bases, so these exponents have to equal each other. 2 to the negative 3rd equals 2 to the negative 3rd, so x has to be negative 3. Number 14. Okay, we have logarithm base 3 of 1/9. We don't know what that equals, so we set it equal to x. Now we're going to write this exponentially, so 1/9 equals 3 to the x. Okay guys, there we go. Now, this is almost identical to the last problem, so if you can finish this on your own, then pause the video and try it. In fact, it is identical to the last problem, so try this on your own, okay? Alright, now, I see right away I have a 3 here and a 9. Obviously, 9 can be easily written with a base of 3. 3 squared is 9. So where the 9 is right here, I'm going to put 3 squared. So now I have 1 over 3 squared equals equals 3 to the x. I don't want this fraction here. So 1 over 3 squared. I bring the 3 squared up, and this 2 becomes negative. So now I have 1 times 3 to the negative 2 all over 1. And of course you don't need these 1s, so I have 3 to the negative 2 equals 3 to the x. So your bases are the same. 3 to the negative 2 equals 3 to the negative 2. X has to be negative 2. On to 15. Well, this is easy, guys. I've told you and told you. I don't care what the base is. Anytime you take the logarithm of 1, the answer is 0. Period. Anytime you take the logarithm of 1, I don't care what the base is, the answer is 0. Okay? Alright, moving on now to numbers. 23 through 27. Well, actually 37 odd. 23 through 37 odd. The next three problems, 23, 25, and 27. The directions ask us to simplify, so we don't type anything into our calculator. We just simplify. Well, I'm going to come down here and give you a different problem, guys. If I had 4x squared times 8x to the third, would that not be so easy for you guys by now? 4 times 8 is what? 32. And x squared times x to the third is x to the what? Fifth. You add your exponents. Students, it's the same thing here. Just look at e. Look at your e. Like it's an x. Okay, they're like bases. So what did we do down here? We took 4 times 8, right? So take 4 times 2, and what do you get? 8. Now, what was your like base down here? X. What's your like base up here? E. What did you do to your exponents? You added them. So what do you do to your exponents? You add them. So we have x squared plus 2x plus 1. I don't see any like terms. You cannot simplify that. So even though your exponent looks really weird, that's your exponent. There it is. Done. Number 25. Okay, let's simplify this again, guys. Look, it's very simple. There's a 1 here, okay? So I start off with my coefficients. 1 and 3. Can 1/3 be reduced? Not at all. Now I look at my like bases. What is my base up here? E. What is my base down here? E. What have I taught you? When dividing like bases, write the like base up top. And then subtract the exponents. You take the top, negative 3, minus the bottom, negative 2x. So negative 3 minus 2x. And that's sufficient for me. And I know their answer's a little different, but that's totally fine with me. They just wrote theirs like this. They called 1/3 a coefficient and then put e to the negative 3, negative 2x. I have no problem with either one of these two answers. Either one is fine, okay? They put their negative 2x first, and then their negative 3. I just put negative 3 first and negative 2x. It doesn't matter. Alright, moving on to number 27. This will be a really good problem, guys. Here we go. This will be a really good thinking problem. We're going to do this 2 different ways, so stay with me, okay? Alright, now first of all, if you want to, there's no plus sign here or minus sign. They're multiplying. So this is one term. So if you want to, you can take the 2 and multiply it through. So what's the power of the 6? 1. What's the power of the e? 20x. What's the power of the 1/2? 1. What's the power of the e? Negative 10. Now this first way that I'm doing this, I do not recommend this first way, but I'm going to do it this way, then show you an easier way. So here we go. We take the 2 and we're going to multiply it through. So 2 times 1 is 2. So 6 squared. 2 times 20x is 40x. Now again, I don't recommend this way, but it's okay to do it this way. Now the 1/2, be careful. The 1 and the 2 get a 2. So it's 1 squared over 2 squared. Be very careful there, okay? And then e to the negative 20x. There we go. Now, 6 times 6 is 36, so I'm going to make this a 36. 1/2, 1 squared is 1, 2 squared is 4, so I really have 1/4, 1/4. So I'm going to put a 1/4 here. So now I have this times this, so here we go. 36 times 1/4 is 9. Now you're multiplying like bases, so write your like base here. And then add your exponents. 40 plus negative 20 is 20x. And there we go. Hopefully that's the right answer. Okay, good, it is. Now, let me show you the other way. This is the way I recommend that you do it, okay? I recommend you first simplify inside of here. So multiply these two expressions together. 6 times 1/2 is 3. You're multiplying like bases, so write your like base here. And then add your exponents. 20 negative 10 is positive 10. And all of that is to the what power? Second. And now here we go. Multiply your 2 through. 2 times 1 is 2. 2 times 10 is 20. X. And of course 3 squared is 9. That's a lot less messy, okay, than this is, in my opinion, okay? But, anyways, that's how you would do that, okay? Make sure you understand this, guys. These are going to be on your test. Alright, 29 through 33, we're going to expand. We're going to expand. I'm going to go really slow, okay? So here we go. We're going to take a logarithm here and we're going to expand it now. You do not want to expand a logarithm when there's an exponent here. So first you have to move that over here. So we have 3 natural logarithm of 2x over x squared. That's the first thing you want to do. Next, we're looking for division. Always look for division first, after you've gotten rid of that big exponent. Well, actually, I'll be honest with you students, I've never really taught it this way before. So let me teach the way I've taught it before. Let's just simplify the argument. Let's do it this way. The other way would have worked, that's fine. Let's do this. There's a 1 here, and a 1 here, and a 2 here. So take your 3 and multiply it through. 2 to the 3rd power, x to the 3rd power, x to the 6th power. Okay? That's the first thing I would do. And then you can simplify your argument here. We can simplify this. So now we have natural log of 8 over x to the 3rd, x to the 6th. Now we're dividing like bases, correct? I'm going to do a bunch of simplifying here, guys, before I try to expand this. If you can simplify your argument, always do that. Now, I'm dividing like bases. So if I'm dividing like bases, you write the like base up top, x and x, and you subtract 3 minus 6 is negative 3. Now we don't want that negative exponent, so bring this down to the denominator, and it becomes x to the positive 3. So this really big expression here for the argument now became this. Back it up and watch it again if you need to, but it's always wise to simplify the argument if you can. Now, let's see if we have division. Always check for division first. Go in this order. Division first, then multiplication, then exponents. Always go in that order. So let's start off with division first, okay? Do you see any division in your argument at all? Any division? Well, definitely right here. And we're dividing two things. We're dividing an 8 and an x cubed. So if we're dividing two things, then how many logarithms do we write? 2. And the top of the fraction goes with the first logarithm. The bottom of the fraction goes with the second logarithm. Do I put a plus sign here or a minus sign? Well, the argument was dividing, so it's a minus sign. Now, look at this argument. Do you see any more division? No. Multiplication? No. Exponents? No, so we're good. Over here, do you see division? No. Exponent? No. Or excuse me, multiplication? No. Exponents? Yes. So we pick the exponent up, and we're going to move it to right here. And that hopefully is the answer. Good, it is. So there we go. Alright, moving on to number 31. Okay, now, we're going to expand this, obviously. So, remember what I do. I look for division first in my argument, then multiplication, and then exponents. But always try to simplify your argument. Now, this argument here cannot be simplified. There's nothing I could do. The last argument, there was all kinds of simplifying we could do to this, okay? Alright, now, okay, do you see any division anywhere? No. Do you see any multiplication? Yes. You're multiplying how many things? 3, 6, an x, and a y squared. So if we're multiplying 3 things, how many logarithms do you write? Obviously 3. First part goes with the first logarithm. Second part goes with the second logarithm. third part goes to the third logarithm. Now, it's all multiplying, so all these logarithms are being added. And do you see any division, multiplication, or exponents here? No. Do you see any division, multiplication, or exponents here? No. But I do see an exponent here, so we're going to have to move that right here to the left. We'll make it a little bigger so it fits in there. And there we go. And that hopefully is the correct answer. And yes, it is. Moving on to number 33. Number 33. Okay, we're going to expand this, okay? Now, first of all, I've told you, simplify your argument when you can. We can definitely simplify that argument. I'm dividing like bases. We'll leave our 2 down here. I'm dividing a y and a y. When you're dividing like bases, write your base ones up top and subtract the exponents. So we have negative 2 minus 1. Use a calculator. If you struggle with sign numbers, negative 2 minus 1 is negative 3. Now we don't want a negative exponent, so bring it down here. And that gives us y to the third power. Okay? So there's my new argument. So I'm going to rewrite it. I have natural logarithm of x to the 5th over 2y cubed. Got it, guys? Look it over again if you need to. Make sure you understand how to simplify the argument. Now, when we're expanding, we always look for division first, then multiplication, and then exponents. Okay, so here we go. Division first. I say division. Don't think you're dividing 3 things. Don't say 1, 2, 3. They're multiplying down here. You're dividing 2 things. 1, 2. That's it. You're dividing 2 things. So you write how many logarithms? 2. The top of your fraction goes here. The bottom of your fraction goes here. And because it's division, you subtract. Now, let's continue on. Look at this argument. Do you see division? No. Multiplication? No. Exponents? Yes. So this 5 needs to be moved to the left over here. Now, look at this argument. Do you see any division? No. Do you see any multiplication? Yes, right here. We're multiplying 2 things, a 2 and a y cubed. So if we're multiplying 2 things, we've got to split this up into 2 logarithms. So 5 natural logarithm of x. Oh, hold everything, guys. We got a problem. This negative sign right here goes to the entire logarithm. So if you're going to take this logarithm and split up into 2 logarithms, this negative sign goes to both of them. So be sure and put a parentheses, because everything you do to this negative sign goes to the whole thing. Because this negative sign went to the whole logarithm. So here we go. We have 2 parts, right? We're multiplying this times this. So we write 2 logarithms. The first part goes here. The second part goes here. Now, they were multiplying, so we put a plus sign here. Now look at this argument. Is there division? No. Multiplication? No. Exponents? No. But over here, there's no division or multiplication, but there is an exponent, so we're going to take that 3. We're going to move it to right here. And now we're almost done. Take your negative sign and multiply it through and you're finished. 5 natural logarithm of x. Negative times a positive is negative. Negative times a positive is negative. And hopefully we didn't make any mistakes. No, we are good. Alright, moving on. Now we're going to condense. Now in order to condense, you must have like bases, and there can be no numbers to the left of each logarithm. Let me say that again. In order to condense logarithms, you must have like bases, and you cannot have any numbers to the left of each logarithm. So, do I have like bases? Yes, I do. Do I have a number to the left of this logarithm? No, but do I have one here? Yes. So the first thing you have to do is pick this up and put it right here. Got it? Now here's the problem. If you can simplify an argument, you really should do that. 9 to the 1/2, guys. Think about that. 9 to the 1/2 means the square root of 9, which is 3. So we can definitely make that argument become a 3. So let's go over this for the third time. If you're going to condense logarithms, first make sure they have like bases. Secondly, any numbers to the left over here, move those as exponents. And then sometimes you can simplify and sometimes you can't. So now we have logarithm base 2 of x plus logarithm base 2 of 3. because 9 to the 1/2 power is 3. Now we're ready to condense. Take these two logarithms, write one logarithm. What are the logarithms doing? They are adding. So if they're adding, you multiply the arguments x and 3. Now I guess you could put x3, but that's really weird in algebra. It would be 3x. And don't forget your base is 2. Alright, moving on to number 37. Okay, now remember we must have like bases. 6, 6, and 6. That's not a good omen, is it? Not good, alright. Just kidding. Alright, now, any numbers to the left? Well, there is here. So I'm going to put a 1/3, 8 to the 1/3. Any numbers to the left here? No. Any numbers to the left here? Yes, right here. So now I have logarithm base 6 of 2 plus logarithm base 6 of x plus logarithm base 6 of y squared. Now, where does 2 come from? Well, guys, come on. 8 to the 1/3 power means the cube root of 8. 8 to the 1/3 power means the cube root of 8. Got it? So, that means I have a 2 because the cube root of 8 is 2. Now I'm ready to condense. I have two logarithms here. Just go left to right. Start with your first two logarithms. These two here will be condensed down to one logarithm. You're adding those two logarithms, so you multiply the bases. 2 times x is 2x. Okay, then bring down your next logarithm right here. Now we're going to condense those two logarithms, so these two become a logarithm base 6. The two logarithms are adding, so we multiply our arguments. 2x y squared. And let me check my book for that answer. Number 37, and yes, that is correct. Alright, number 39, or 38, excuse me. Okay, we're going to condense this logarithm now. Do we have the same base? Yes, we've got an e and an e and an e. Do we have anything to the left? Yeah, we got all kinds of stuff. First of all, you've got a 2 here that needs to be multiplied through. So the first thing I have is 1/2 natural logarithm of 4. And then positive 2 times positive logarithm is positive 2. And then positive 2 times a negative logarithm is negative 2 natural logarithm of 2. So I took this 2 and I multiplied it here, and I multiplied it here. Okay? Now I've got all kinds of numbers to get rid of. This 1/2 has to go right here. This 2 has to go right here. And this 2 has to go here. So now I have the natural logarithm of 2 plus the natural logarithm of 36 minus the natural logarithm of 4. 2 times 2 is 4. 6 times 6 is 36. And 4 to the 1/2 means the square root of 4, which is 2. So we're good now. Here we go. Take these two and condense them down to one logarithm. They're being added, so we multiply our two arguments together. 2 times 36, 72. And then bring down your next logarithm. Now, condense these two down to one logarithm. And they're subtracting, so you divide the two arguments. 72 divided by 4, which is 18. So there we go. Natural logarithm of 18. Let me check the book real quick. And that is correct. Alright, moving on now to numbers 40 through 48. Now, these are solving equations, okay? Solving equations. I've given you quite a few of these, but we need the practice. So here we go. Alright, students, let's solve our first equation, the logarithmic equation. Now, step 1, I've taught you to isolate the logarithm, and we've done that. Step 2, then write it exponentially. Okay, the logarithm is isolated. Here's your word, here's your argument, and the base. It's isolated. So now we're going to write it exponentially. X equals 4 to the 3rd power, which is 64. Now remember, with logarithmic equations, you must check your answer. You must. So you pick up your number and you put it in for the argument. Do you have a positive argument? Yes, you do. So we're good. So the answer is 64. Alright, number 41. This is called a logarithmic equation. Got it? Logarithmic equation. Step 1 is isolate the logarithm. So there's the word, there's the argument, they're all by themselves. So it is isolated. Step 2, write the problem exponentially. There's a base e here. So x equals e to the 5th. So type that into your calculator. E button, 5, enter, and you'll get this right here. Now, check your answer. Anytime your original problem was a logarithmic equation, you must check your answer. So if I pick up this answer and put it in for the argument right here, will I have a positive argument? Of course I will. Positive 148, definitely. Number 42. Okay, another logarithmic equation, okay? So here we go. Step 1, isolate the logarithm. Well, here's my word. Here's my argument and base. Yes, it's isolated. So step 1 is done. Step 2, write it exponentially. So 256 equals x to the 4th power. Now, this is not an exponential equation. An exponential equation would have the 4 down here and the x up here. In order to have an exponential equation, you must have the unknown in the exponent. We do not. We have the unknown down here for the base. So there. Now guys, you know how to solve this. I don't want x to the 4th. I want x. So how do I get rid of an x to the 4th? I take the 4th root of it. But if I take the 4th root of one side, I better take the 4th root of the other side. Now, 2 questions. Did you insert? Did you insert the root, the radical? Yes, you did. Is the index even? Yes. So you must put plus minus. Alright? Now, the 4th root of 256 is 4. But in case you didn't know that, use your calculator. You would want to type in 4 on a graph. If you have a grapher, type in 4 first. Then hit math. And then option number 5. And this will pop up on your screen. And then type in 256. And you'll get out 4. So the answer is positive negative 4. So you think you're done. But the answer is only 4. And here's why. You can never have a negative base in a logarithm. That's by definition. The definition of a logarithm is this has to be positive, so you cannot have a negative base. So your answer is 4. Done. You can't have a negative 4 because you can't put a negative 4 here for a base. Always check your answers on these guys. Always. 43. Okay, now we're dealing with an exponential equation. Does everybody see that? An exponential equation. Step 1, isolate the exponent and its base. Well, here's the base. Here's the exponent. They're isolated. Step 2, try to write both sides with the same base. Well, guys, that's not possible. You can't write a 10 with a 4.3 or write a 4.3 with a base of 10. So the next step is take the logarithm of both sides. So take the logarithm of both sides. Got it? Now, what is the base of your unknown? 10. Whatever this base is, that's what you want to put here and here. Now bring down the whole left side. Bring down the whole right side. And now let's get to work. Whenever this number matches this number, everything's gone but the exponent. So x equals logarithm base 10 to 4.3. Hold it. Our calculator does base 10. All I have to do is hit logarithm, button, and then 4.3. So if you hit log and then 4.3, you will get this right here. 0.63346845556. We're going to round to here. Now, we don't have to check our answer. It's not a logarithmic equation. It's an exponential equation. So we're good. This is our answer. Alright, number 44. Okay, we have another exponential equation. We know that because the unknown is in the exponent. Got it? So, step 1, isolate the base and the exponent. Here's the base, here's the exponent. Isolate them. Well, they're isolated. Step 2, try to write both sides with the same base. That's not going to happen here. Step 3, take the logarithm of both sides. So logarithm, logarithm. Now here's your unknown. What's your base? E. So because your base here is an E, you put an E here and an E here. Now bring this whole left side down. Bring this whole right side down. And there we go. When this number matches this number, everything's gone but the exponent. X equals logarithm base E just means natural logarithm, right? Of 6. So with your calculator, type in natural logarithm of 6, hit enter, and you'll get 1.79175946.9. We're going to round the 3 decimal places. 1.79. That should be a 2 right there, actually. If you round correctly, that should be a 2. But I'm not that picky about that kind of stuff. Now, you don't have to check your answer because our original problem was not logarithmic. So this is your answer. We're good. Number 45. Okay, now we have a logarithmic equation, correct? Logarithmic. So here we go. Isolate the logarithm. Well, here's the word. Here's the argument. They're totally isolated. So step 2, write the logarithmic equation exponentially. So 729 equals x to the third power. Now, guys, this is not an exponential equation. If it was an exponential equation, it'd be 3 to the x power. See the difference? Your unknown has to be up here in the exponent. For it to be an exponential equation, we don't have that. This is just a good old third degree equation. How do we make an x cubed become x? Well, we take the cube root of it. Well, if you take the cube root of one side, you must take the cube root of the other side. Now, do we have to put plus minus? Well, let's see. Did you choose to put the radical in? Yes, you did. So far, so good. Is your index even? No, it's odd. So no, you do not put plus minus. Now the cube root of x cubed, of course, is x, and the cube root of 729. If you have a grapher, just hit math option 4, and cube root will pop up on your screen, and then type 729, and hit enter, and you'll get 9. All right. Now we do have to check this. It's a logarithmic equation. Check your answer. Pick up your answer 9 and put it in for x. Is my base positive? Yes, it is. So we're good. The answer is 9. Number 47, or 46, excuse me. All right, now this is an exponential equation. How do I know that? Because my exponents, my unknown is at the exponent. My variable's in the exponent, so I have an exponential equation. Step 1 is to isolate the base and the exponent. Here's my base, here's my exponent. You've got to get rid of this 3 and this negative 4. Got it? Always get rid of the multiplying number last. So I'm going to bring the positive 4, the negative 4 over and make it a positive 4. So now I have 3 e to the negative x equals 13. Got it? Next, divide both sides by 3. So I have e to the negative x equals 13 over 3. There, I've done it. I've isolated the exponential. Now, you want to write both sides with the same base. That's not happening, obviously. So the next step is to take the logarithm of both sides. So I'm going to put a logarithm here and a logarithm here. Okay, now what is the base of my unknown? E. So put an e here and an e here. And then bring down this entire left side. Bring down the entire right side. And now let's see what happens, okay? Whenever this number matches this number here, everything's gone but the exponent. So negative x equals logarithm base e means natural logarithm of 13 over 3. And now x is not quite by itself. Look at it like there's a negative 1 there. You gotta divide both sides by a negative 1. Okay? So guys, divide both sides by a negative 1. These will cancel, leaving you with an x. And over here you're left with natural logarithm of 13 over 3 divided by negative 1. Now, here's how you would type this in. If you'll listen carefully, I will teach you how to do this, okay? With your calculator, type in, use your LN button, and then 13 divided by 3, and then close the parentheses, and hit enter. You should have 1.46633769. Then hit divided by negative 1, enter, and you'll get negative 1.466. Now, you do not need to check this because your original problem was not a logarithmic equation, so you're good. That's your answer. 47. Okay, good. Another exponential expression, another exponential equation. Good. Okay. Step 1 is to isolate the base and the exponent. So I've circled those. You've got to get rid of this and you've got to get rid of this. Okay. So first of all, let's bring the 10 over. It's a positive 10, not because of this right here. It's a positive 10. Bring it over and makes it a negative 10. So 0.1 e to 3x equals 8. Alright, now divide both sides by 0.1. These cancel and you're left with e to the 3x equals 80. Alright, now is my exponential isolated? Yes, it is. So the next step is write both sides with the same base. Obviously, it's not going to happen, so we're going to move on. Take the logarithm of both sides. So logarithm, then equal sign, then logarithm. What is the base of your unknown? E. Put an E here into E here. Bring down your entire left side. Bring down your entire right side. And here we go. When these two numbers match, everything's gone but the exponent. And over here, logarithm base E just means natural logarithm of 80. Divide both sides by 3 and x equals natural logarithm of 80 all over 3. So, with your calculator, type in ln of 80, enter, divided by 3, enter, and you will get 1.4606755545, which rounded is 1.461. Okay? Alright, one more problem, and we'll take a break and do a part 2 a little bit later. Alright, so here we go, 48. Alright, now let me see what's next. What do we have next? Graphing. Maybe we can do the 4 graphing problems and then take a break. We'll see how it goes. Alright, 48. Let's solve this exponential equation, okay? So step 1 is to isolate the base and its exponent. Here's your base, here's the exponent. So we must get rid of the 2. We'll divide both sides by 2. And we're left with this. 3 to the 2x power equals 2.55 divided by 2, 2.5. Step 2, write both sides with the same base. Well, obviously that's not going to happen. So step 3, take the logarithm of both sides. Now, what is the base of my unknown? 3. So we'll put a 3 here and a 3 here. Bring down your entire left side. Bring down your entire right side. And here we go. Whenever these two numbers match, everything's gone but the exponent. And over here we have logarithm base 3 of 2.5. Now divide both sides by 2. And x equals logarithm base 3 of 2.5 all over 2. Now, please listen to me carefully, students. Your calculator does not do base 3. So we're going to have to rewrite this numerator right here like this. Logarithm of 2.5 over logarithm of 3 all over 2. So this expression right here became this right here. You have to understand that, guys. Your calculator does not do base 3 logarithm, so you have to rewrite it with a change of base formula. So now with your calculator, type in log 2.5, enter, be sure and push enter, divided by logarithm of 3, then push enter, then divided by 2, enter, and you'll get 0.41702188836, alright, or 0.417, alright. Guys, this will be a really good stopping place here. That's been